the audio on? Hello? Okay, welcome to this recording. Here's the problem from Chapter 3 we're going to be looking at. We're going to calculate a percent of the area under the curve of the standard normal distribution that's outside the interval z equals negative 2.66 and z equals 2.66. In other words, we're looking for the area that's more than 2.66 standard deviations from the mean. Before we jump into the calculation here, there's a couple of keywords and notation I want to notice. First of all, they're telling us it's a standard normal distribution. So that's another way of telling us what the mean and the standard deviation are. A standard normal distribution means the mean is 0 and the standard deviation is 1. And this is reflected again in the notation that they're using the variable z. A variable z in statistics always indicates that we're dealing with a standard normal, so our mean is 0 and a standard deviation is 1. And when someone tells us a z-score, they're really telling us how many standard deviations from the mean we are. So here we have a z-score negative 2.66. It means we're 2.66 standard deviations below the mean. And they're asking what percent of observations are going to be 2.66 standard deviations below the mean, or 2.66 standard deviations above the mean. So let's get out our whiteboard and take a look at how we would write out and solve that answer, show that answer. So here's our whiteboard. All right, let's get a good color. And begin by writing our given information that we have a normal distribution, standard normal, so normal distribution with mean 0, standard deviation 1. And then we want to draw a picture of that normal distribution, of that normal curve. So we can illustrate what we're looking at here. So there's the curve. Now let's see if I can get a good, or there's the horizontal axis. Let's see if I can get a good normal curve here. Take my time, try to make it come out look pretty good. Alright, hopefully yours probably looks better, but that's the best I can do on a computer there. We know our mean is going to be 0. Standard deviation is 1. We've indicated that in our given information. And now we're looking kind of the values of interest that they gave us on the horizontal axis were z values of 2.66. So if we think our inflection point is 1 standard deviation, 2 standard deviations might be there. 2.66 is going to be pretty far out here. So there's 2.66. And we need negative 2.66, so somewhere down here. And then if we look back at the question, they're looking for the area outside those values. They're saying what percent of observations are outside this range. So they're talking about not the area in between, but the area over here in this tail, and up here in this tail. So we've got a couple options to solve this problem. First of all, we could calculate this area, and then calculate this area and add it together. Another thing we could do is calculate the area in the middle of them and then subtract that from 1, because we know the total area under the curve has to be 1. But let's begin by just saying we'll take the approach where we calculate this area. We want to find what is that area right there, because that's really what the question is asking, what's the area outside that range of values. So we can think about, do we want to use the inverse norm command or the normal CDF command here? Whenever we're given a value on the horizontal axis and we're looking for an area, normal CDF will tell us the area. So we can use normal CDF. So we're going to use norm CDF here. Whenever we use norm CDF, the first number we have to enter is the left-hand boundary of the shaded area. In this case, that area goes out to negative infinity. Our calculator doesn't have a negative infinity button, so instead we're going to put in negative 1 E9. That's scientific notation indicating a negative 1 with 9 zeros after it. In other words, a really negative number, pretty close to negative infinity. And then the right-hand boundary of that area is negative 2.66. And then we need to put in our mean and our standard deviation. So our mean is 0, and our standard deviation is 1. So if I to go ahead and enter that on my calculator. To get that on the calculator, I'm going to do second vars, choose option 2, norm CDF, and then I've got -1, E9, and then -2.66, and then a 0, and then a 1. And that's giving me a very small decimal number. It's giving me 0.0039. So this is a very small area here. 0.0039 out of 1. In other words, less than 1%. Close to 0.4% there. Now we want to think about, that's not our final answer, because it asks for this area and this area. So we need to calculate this area as well. Because the center of this distribution is at 0 and the normal curve is symmetric, we know that this area will be the same as that, because this is the same number of standard deviations, 2.66, away from the mean, as this one is below it. So we know that this area will also be 0.0039. But if it's not clear to you why that is, if you have any doubt at all that that would be true, I think it's a great idea to go ahead and verify that on your calculator. You can do that using the norm CDF command again. To find an area, it's going to look very similar to what we did before, but a little bit different. We're going to use the norm CDF command. We're first going to enter the left-hand boundary of that area, which is 2.66. Then we're going to enter the right-hand boundary, which is infinity. That area goes forever. So we're going to enter 1E9. How the calculator deals with positive infinity, just a really big positive number for a normal distribution. And then 0 and 1. And if you go ahead and put that in your calculator, if you do second vars, normal CDF, 2.66, and then 1E9, and then 0, and then 1, right, we're getting that same number, 0.0039. So are we done yet? Well, almost. To find the total area in blue here, we're going to need to say, we're going to add those two together, those two areas. So the total area, sorry, writing on this is not the easiest thing. The total area in blue is going to be 0.0039 plus 0.0039. You've probably already done it on your calculator while I'm writing it out here. Plus 0.0039. And I think when you do that out, you get 0.0078. Let me just verify. Yes, indeed. So we're going to get 0.0078, which is the decimal answer. Notice WAMAP asked for it as a percent. To convert a decimal to a percent, we want to multiply by 100 or slide the decimal point 2 places to the right. So as a percentage, it's going to be 0.78%, less than 1%. 0.78% of the area under the normal curve is more than 2.66 standard deviations away from the mean. Indicating, about 99%, right? This is less than 1, so more than 99% is in between those two values, and you can think about, does that make sense with what we know from the empirical rule, that 68, 95, 99.7% rule? And it does, because that rule tells us if we go out 2 standard deviations, we've got 95% of the area in the middle. If we go out 3 standard deviations, we're going to have 99.7% of the area in the middle. So now we're going out a little more than 2.5 standard deviations. We should have somewhere between 95 and 99.7% of the area here, and we do. We have about 99%, a little over 99% in between, because we've got a little less than 1% on the edges. Let's go back to that WAMAP one so we can just verify how we would enter our answer there. So here what we're going to do is we're going to do, it was 0.78%, so that's what we would enter, and then let's just verify, yeah, that's what it was looking for, 0.78. All right.